All right, 2.3 functions. So to start out with, it says to decide whether each relation defines a function. So there's different ways we can do that, but they give us the relation, the set of ordered pairs, 8, 0, 5, 7, this is going to get annoying, 9, 3, and 3, 8.
Good morning.
Good morning.
Any absences?
No.
Thank you.
I always forget to do that. All right, so then we have this relation, and we're going to see if it defines a function. And so if there are any x values, basically they get repeated, then it is not a it is not a function. No, you're good. Thought you were coming to join us.
No, I don't have any unction in my function, so.
So I'm going to do a mapping diagram to figure that out. So we're going to have input and output. So the inputs are going to be the x values, and I like to write them in number order because, you know, it's just how my brain works. So 3, 5, 8, 9. And then output 0, 3, 7, 8. And then we connect them with what they go with. So 3 goes with 8, 5 goes with 7, 8 goes with 0, and 9 goes with 3. So as long as there's only basically one line coming out of each of these input values, it is a function. So this one would be a function because there's no repeated x values. Uh, 14, I'm going to show you a different way we can do this. We've got 9, -2, -3, 5, and 9, 1. So the other thing you can do, because this book doesn't specify what method you have to use to tell if it's a function or not. So if you are like, I don't want to do all the extra writing and stuff, you can just underline in there that there are two x values that are the same, and then just basically say not a function because there are repeated x values. And that would be sufficient. So then the next problem, say to decide whether each relation defines a function, which is literally what we just did, and then it says give the domain and range. So domains are going to be our x values, range are going to be our y values. So that's another way we could do these problems. So I'll show you the other way we can look at these problems within doing domain and range. So 20, the relation we have is the 0.25, 0.37, the 0.39, and the 0.511. So first and foremost, is this a function? No, why not? There's 2 3s, so it's not a function. And the second part of this says to list the domain and range. So the domain are the x values, and we only write them one time if they're repeated. So like since I have 2 3s, I'm only going to write it once. So it's going to be 2, 3, and 5. And then range is going to be 5, 7, 9, and 11. And so another way to look and see if you have a function or not is if there are less domain values than there are range values, then that means that it is not a function. And so that's kind of the same thing. If there are less input values than there are output values, it would be not a function. Because they all tell you the same information, just in a different way. So now they've been giving it to us as a relation written out with the ordered pairs. Another way they can present you with the information would be like 24. They actually give you a little table that's got X and Y values in it. And so basically all this is they're giving you the ordered pairs, just not written as an ordered pair. So 0 is with 0, 1 is with -1, and 2 is with -2. So that being said, would this be a function? Because there's no X values that get repeated, right? It's just 0, 1, and 2. None of those are repeats, so this would be a function. And then these are still asking for the domain and range, so when it does that, domain is just whatever your X values are, so 0, 1, and 2. Range is your Y values, 0, -1, and -2. And yes, I wrote those in reverse numerical order, but that's fine. All right, the next ones you're going to actually need your book open for to be able to look at them, because I won't be able to copy them over perfectly. They're graphs. It's on page 215. And we're going to start at number 28. So we've got a parabola that is open down. So at 4 up here, that would be the vertex, and this would be -3. It's doing something like that approximately. And they want to know if this is a function or not. Does anybody remember how we tell if a graph, how to know if it's a function or not? What test? Yep, the vertical line test. So I basically take my pencil and lay it down, and I go across, and as long as the graph only intersects at one point in my pencil, then it is a function. Okay, so this one is a function, yes. And I would just know that's because it passes the vertical line test. It's always good on a quiz or a test if I give you a graph or something like that to explain why it is or isn't a function, because if you happen to write the wrong thing, like let's say a lot of times people mix up if there can be like more domain values than range values and vice versa. They get confused, and so if they just tell it to me like why they said that, then I'll be like, oh, they mixed them up, rather than just saying, oh, it's not a function, and I'm like, well, why? Or, in this case it is a function. So these still are under the section of wanting domain and range. So the domain is all the X values that it takes on. Well, a parabola, I'm going to do it up because it's easier to hold my hands like this, technically is going out to infinity, and the farther out it gets, it's spreading out over all the X values. So my domain is going to be all real numbers. So you can either do negative, like write it as negative infinity to infinity, or you can write this fancy R, which means all real numbers. It's basically an R with 2 sticks instead of 1. But they both mean the same thing. Or you can just handwrite all real numbers if you're confused. So then it also wants range, and so range is all the y values that it takes on. So what y values would this function take on?
4 to -infinity.
Yep, -infinity to 4. And we include 4 because it goes up and it hits that point there. So that's going to be a bracket on that side. All right, number 30, just to look at another one of these really fast. So I've got the origin up here at 3, -3, 4, -4. It's going to try to make that into a circle, so I'm just going to not even try. So, ignoring my ugly picture, what shape are we dealing with?
Circle or oval.
An oval. Okay. So, is this going to pass the vertical line test?
No.
No, because at pretty much every point there, or at every x value, there are 2 y values that it takes on. So this is not a function. Because it does not pass the vertical line test. And VLT is my abbreviation for vertical line test. I don't think I said that earlier. So what would my domain be for this? What x values does it take on?
4. -4 to 4.
And do I include or not include?
No.
Yeah, I include them because the point is actually at it. So it's going to be in a bracket, -4 to 4, and another bracket.
Exactly.
Definitely what you said, right?
Yeah.
All right, and then my range, what y values does it take on?
3 to 3. 3 to -3.
Yep. And including again, so -3 to 3. And always make sure you write them in numerical order. So like write the negative first, then the positive. Otherwise, it's wrong.
I thought that was actually a circle.
You said you thought it was a circle?
That was supposed to be a circle.
Oh, no. I can make a perfect circle. I just can't make an oval. I don't think. Maybe it'll, well, it might. It kind of lets me, but I think it would have changed that to a circle because it wouldn't have thought that that's what I was trying to do. Why is this getting so blurry? Okay. Next thing. All right, decide whether each relation defines y as a function of x, give the domain and range. So 38, y equals -6x plus 4. So if I were to graph this, what would it graph?
So you have to go up 4, right? Or over 4. Something like that.
Well, what shape?
Oh, that'd be like a line.
A line, okay? A line that would be basically graphed, and these don't require you to graph them, but basically up here at 4, and then I would go down 6 and write 1. And then I would have a line that definitely is a line. Okay, close enough. So I would have a line. Okay, so does this pass the vertical line test?
Yes.
Yes, so this is a function. What domain values is it?
All of them.
Yep, all real numbers because it takes on every x value because the line just keeps going forever and ever. How about range?
-6 to 4 or 4 to -6.
All real numbers. The line keeps going out to infinity.
Oh yeah. What's 3 exclamation mark?
3 factorial, 3 times 2 times 1. If you have a number with an exclamation point behind it, you multiply all the numbers before it together.
Oh, so
So like if you had 5 factorial, it'd be 5 times 4 times 3 times 2 times 1.
Didn't y'all do that last year?
No. Maybe I did.
I think it's in the book, but it's a section that we don't normally get to because of just where it is. There's usually not time to get there. Teachers that cover entire math books, I'm like, how do you do it?
Yeah.
I say that, and last year I covered the entire, basically the entire college algebra book. They were like, can we stop now? Because I was not planning to get that far, and I was like, no.
Are we going through this whole thing?
Well, I should say, I think I got through chapter 9 last year.
So can we just like stop it?
I didn't do 10. But I also skip a few sections in the middle just
We just
because.
stop at like 5.
Yeah, no. All right, 40 x minus y is less than 4. So I need to determine if y is a function of x. So what might I need to do?
Get x over there. Forget y over there. Something like that.
Get y by itself. Is that what you're trying to say?
Yes.
How would I do that?
Subtract x. Also.
Subtract x, so that gives me negative y is less than negative x plus 4.
And then do the old subtraction thing. But it
Subtraction
should be
thing.
y is greater than
Yep,
x minus 4.
yep. So, is this a function?
Yes.
What does a graph of an inequality look like?
But it's probably not because
Like, what happens when we graph an inequality normally? What do? We graph the line and then what?
Is it the dotted thing?
Okay, yeah, this one would be dotted.
Oh, you do the line investment.
That's for scatter plots.
yeah, come on.
So I would have down at negative 4, up 1 over 1, so on and so forth. It is dotted because it is greater than. But what would the next thing you tell me to do now be? Shade above. And shading is because of what?
That's the way that is like.
Because any value I plug in from this shaded area makes this statement true, right?
Yes.
So that means there are a lot of values for x equals 1, for example, that make this true. So would this be a function?
Yes.
No. Not a function. Domain is still what?
Nothing.
It's the same as 38.
Probably all real numbers. I would say.
All real numbers and range.
All real numbers.
All real numbers. Alright, I'm going to show you one more, but I'm going to show you it more as a generic problem rather than the problem that's in the book. So I'm going to modify 46 to be y is equal to the square root of x. They have 7 minus 2x, which just manipulates what it looks like a little bit. Anyone know what a square root function looks like on a graph?
Is this triangle?
Anyone else have an idea? You may or may not have ever seen a square root graph before. So it looks something like this.
Oh, yeah.
So it starts at 0 because we can't ever have negative numbers, right? For a square root. It's like word's not working. The only way I could have that is theoretically in the problem that it actually gives you in the book. You could because of the problem the way it asks it. But in general, a square root cannot be negative inside because otherwise it's an imaginary number. So this would be what this graph looks like. So would this be a function?
Yes.
Yes, it passes the vertical line test, so this is a function. The domain of this would be what? What x values does this take on?
The positive ones. The
Yep.
0 to
0, and we can include 0 because it starts there and 0 is acceptable to have inside there. So 0 to infinity.
Yeah.
How about range?
Doesn't it stop at a certain?
It's
all real.
stop/starts right here, but it keeps going out to infinity.
So infinity.
It keeps going up too.
It keeps going up. As it goes farther out, obviously it's gonna get higher, but it just doesn't really look like it. So this is also gonna be 0 to infinity for my y values. All right. All right, the last problems give us, they tell us f of x is equal to negative 3x plus 4, and g of x is equal to negative x squared plus 4x plus 1. And then they give us problems of things that we need to find. So like the first one is f of negative 3. So all we have to do for that is anywhere there's an x in this function, we put a negative 3. So negative 3 times x is negative 3 plus 4 would be what? $13. So it's 9 plus 4, 13. Let's do one for g and then we'll be done unless y'all have questions. G of negative 1/4. So your favorite thing, I'm sure, fractions. So anywhere we see an x in this function, we are putting negative 1/4. So I have negative and then in parentheses negative 1/4 squared, and that's important because this squared is on the negative 1/4. Okay, so we have to do that first and then multiply it by the negative that was there to begin with. Plus 4 times negative 1/4 plus 1. So what is negative 1/4 squared? 1/16.
Exactly.
So because of the negative out front, it's going to be negative. This negative in here becomes positive. So negative 1/16. And then over here, 4 times negative 1/4. 4s are canceling. So I'm left with negative 1 plus 1, which ends up giving me negative 1/16. So your problems are, go back and make sure I don't give you anything we didn't do. 11, 13, 19, 23, 31, 37, 45, 53, and 55. So again, you don't have to like copy the graphs over on the ones where they give you a graph or anything, and you don't have to, you can pick whatever method to say if it's a function or not. Just make sure you give enough that if I were to go look at it, I could see why you put function or not a function. So at least make a little statement about why it is or isn't.